Hello and welcome back to Math 121. This is a video over section 1.2, and this is about linear equations and rational, should say equations. So let's go up there and let's change this from expressions to equations. Okay, and we're going to be solving equations. And when we solve equations, we want to think about opposite operations. Okay, we often call these inverse operations. But for right now, opposite / inverse operations. Okay. And so let's do this. Let's talk about all the different operations that we currently have. The opposite of addition would be subtraction. Okay. The opposite of multiplication would be division. There's a couple others that we can talk about. The opposite of taking something squared would be taking the square root of that. Okay, those are opposite operations. Now, a solution to an equation. So a solution makes the equation true. Okay, and we're going to be checking our solutions to just verify that we have the right answers. Okay, so let's kind of just jump into this first example here, and we want to solve and check. So I've got 4x plus 5 equals 29. So what I want to do is isolate x and solve for x. Okay, so I'm going to subtract 5 from both sides. Okay, and I'm doing the opposite of what it's telling me, the opposite of adding 5. All right. So then what I have is I have 4x, 5 minus 5 cancels out to 0. Okay, and then I have 29 divided by, or 29 minus 5, which is going to be 24. Okay, and then I'm going to divide both sides by 4 because I'm taking 4 times x. The opposite of multiplying by 4 is dividing by 4. And so then the 4's divide out to 1, and we're left with x is equal to 6. Okay, and this is my answer. Now, what I want to do is check, okay? And you don't always have to do this, but it's important that we understand that concept, okay? So on something like this, what I want to do is I just want to plug in 6 in for x of my original equation, okay? And see if we get a true statement. So I'm going to do 4 times x, which is, we got 6, add 5 to that, and we should get 29. Okay, so let's do the math, and let's see that we do, in fact, get 29. So 4 times 6 is going to give me 24, all right, plus 5, and that's going to equal 29. Now, 24 plus 5 does give me 29, which equals 29. Now, what I'm looking for is a true statement, that one side of the equation matches the other side, and that this is true. Therefore, this is my answer. So you have the ability to check to see if you are right, okay? Let's go ahead and take a look at the next one. This one's a little bit more involved. We've got, some parentheses. We've got the variable on each side of the equal sign. So the first thing I want to do is eliminate the parentheses. And by doing that, I want to distribute what's on the outside. So I'm going to distribute the 4 here, distribute the 3 here. All right, so what I have, 4 times 2x is going to give me 8x. Okay, and then 4 times 1 is 4. So I get 8x plus 4, and then I get 29 plus, let's distribute the 3. So I got 3 times 2x, which is 6x, and then 3 times negative 5 gives me minus 15. Okay, now what I want to do is look at each side of my equal sign. So I have my left side, I have my right side. I want to see if I can combine any like terms. Okay, the like terms I can combine over here is the 29 and the negative 15. So 29 minus 15 is going to give me 14. So I have 14 plus 6x, and I have 8x plus 4. Okay, at this point, you can move things to either side of the equal sign. Typically what I do is I try to get my variables on the left side of my equal sign. It kind of also just depends on the numbers, okay? Typically, I like to work with positive numbers. So I would move my 6x over to the other side of the equal sign. So let's do that first. I'm going to subtract 6x from both sides. Okay, that's going to cancel out here. And then I have 8x minus 6x, which gives me 2x, plus 4, and that's equal to 14. All right, at this point, what I want to do is, we're back to the same problem we had in the previous example, where now I'm just going to subtract 4 from both sides. And that's going to give me that 2x is equal to 10. Then I divide by 2, divide by 2. 2's divide out, so then x is equal to 10 divided by 2, which is 5. Okay. Now, I'm not going to check. I probably should. Let's go ahead and check it. All right. So what I'm going to do is plug in 5 in for x. So I've got 4 times the quantity, 2 times 5 plus 1 is equal to 29 plus 3 times 2 times 5 minus 5. All right, so order of operations says I need to do what's inside the parentheses first, and I'm going to do my multiplication inside that parentheses. So I've got 4 times 10 plus 1 is equal to 29 plus 3 times 10 minus 5. Okay, so then what I have at this point is I'm going to do 4 times 11, and that's equal to 29 plus 3 times 5. Okay, 4 times 11 is 44. All right, and then I've got 29 plus 15. Now, 25 plus 15 is 44. So 44 is equal to 44. That's true, okay? And this is how I check. All right, so this is good. X is equal to 5. All right, so I would say that, it's something that is a good habit, especially if you're really trying to figure out if you're right or not, is a good way to check. Let's take a look at the next one. Now, the next one is a rational equation, okay? And this is a rational equation because we have fractions here, okay? Now, what I want to do when I have a rational equation is I want to eliminate my fractions, okay? And I do this by multiply each term by the common denominator, okay? This will make your life a lot easier. There are other ways to do this, but this is the easiest, okay? So my common denominator, thinking of the numbers 4, 14, and 7, my least common denominator is going to be, with all those numbers, is going to be 28, okay? And I know that, simply because I can list out my multiples. I got 4, 8, 12, 16, 20, 24, 28, okay? With 14, I've got 14 and 28. Okay, with 7, I've got 7, 14, 21, and 28. 28 is my lowest number out of all those, okay, out of all those multiple lists. All right, so what I want to do is multiply each of these numbers, each of these terms, by 28. So I'm going to multiply this by 28, multiply this by 28. Okay, and when I do that, here's what's going to happen. All right, let me do this work over here. All right, so let's take 28, and I'm going to take 28, let me use black, 28 over 1 times x minus 3 over 4, okay, so I've got that value, is equal to 28 over 1 times 5 over 14 minus 28 over 1 times x plus 5 over 7. Okay. Now, why I did this is because I want to look at this numerator here and my denominator here. Same thing with 28 over here and 14 down here, 28 here and 7 down here. In each of these problems, because I am multiplying by 28, I can do some cross division, okay? And I'm going to take 28 divided by 4, and that's going to divide out to 7 over 1. Okay, if I take 28 divided by 14, that's going to be 2 over 1. If I take 28 over 7, that's going to be 4 over 1. Okay, now the reason why I did this is because all my denominators divide out to 1. Okay, that's why I multiply by the common denominator. So now what I have is this. I have a linear equation. 7 times x minus 3 is equal to 2 times 5 minus 4 times x plus 5. And now we have something that we had in the previous example. So what I'm going to do now is I'm going to distribute my 7. So I'm going to get 7x minus 21, and that's going to equal 10 minus 4x minus 20. Okay, so now what I'm going to do is I'm going to collect my like terms. So I've got 10 minus 20. That's going to give me negative 10. So I've got negative 10 minus 4x on my right side. I've got 7x minus 21 on my left. Okay, from here, I'm going to add 4x to both sides. Okay, those are going to cancel out. That's going to give me 11x minus 21 is equal to negative 10. I'm going to add 21 to both sides. Okay, so those are going to cancel out, and I've got 11x is going to equal positive 11. I'm going to divide by 11 on both sides, okay, and that's going to give me that x is equal to 1. 11 divided by 11 is 1. Okay, and so that's it. That's all I'm doing, all right? And so hopefully, you know, when you see something like this, it might freak you out. However, follow this prompt here, and that will eliminate your fractions and have something easy to work with. Okay. Now let's take a look at the next problem. Okay. Now this one is a little bit different. Notice the difference between this problem and this problem. The difference is that in the denominators here, you simply just had numbers. Okay. Now down here, you have variables, all right? So we have to take something into an account. Okay, remember what we did in the last section is we talked about restrictions on the domain. So we have restrictions, okay, when we solve this type of problem. What I'm going to do is take my denominator, which is x minus 2. I'm going to set that equal to 0. And when I do that, I'm going to solve for x. I'm going to add 2 to both sides. I get that x is equal to 2. This value makes the fraction undefined. Okay? So we have to do that before we solve. Now the next thing I want to do is find my least common denominator, LCD. Okay? And I've got x minus 2 in a denominator, and I've got x minus 2, so these are the same. That's good. And then I have a denominator of 3. So my least common denominator is simply going to be 3 times x minus 2, the product of those two things. Okay, so my LCD is going to be 3 times x minus 2. All right, so now I'm going to multiply everything by that number. All right, so let's do this. Let's write this out. We've got 3 times x minus 2 over 1 times x over x minus 2 is equal to 3 times x minus 2 over 1 times 2 over x minus 2. And then I'm going to do minus 3 times x minus 2 over 1 times 2 over x minus 2. Okay? And so at this point, what I'm going to do is I'm going to start dividing things out. Okay? And I'm going to put this in parentheses. Oh, wait. Okay, this should be a 3. Okay? All right, so let's start dividing things out. Okay, so here my x minus 2's are going to divide out. Here my x minus 2's are going to divide out. And here my 3's are going to divide out. So what we're left with is this. All right, we're going to have 3 times x is equal to 3 times 2 minus x minus 2 times 2. Now, once I've done this, I've gotten rid of my denominators. Okay, so we're back to a linear equation, which is nice. Now, the first thing I'm going to do, this part over here with the subtracting this whole quantity, there's a couple different ways you can do it, but what I'm going to do is I'm going to switch these two terms around, okay? I'm going to switch them around. So let's write that out. I got 3x is equal to 6, 3 times 2 is 6, minus 2 times x minus 2. The reason why I'm doing that, because I'm going to distribute the 2, but I also have to distribute that negative, so I'm going to kind of do that in one fell swoop. So distribute that negative 2. So I got 3x is equal to 6 minus 2x plus 4. Now, I'm going to combine my like terms. 6 and 4 gives me 10 minus 2x, and that's going to equal 3x. So I'm going to add 2x to both sides. Oh, look what we get. Okay, so I'm going to get 5x is equal to 10. Now, I'm going to divide both sides by 5. And look what we get. Okay, the 5's divide out. X is equal to 10 over 5, which is going to give me 2. Now, remember, we had a restriction on our domain. Okay, x equals 2 makes the fraction undefined. So if I plug 2 back into this, we're going to get an undefined statement. Now, algebraically, that's what we got. We got x is equal to 2. However, because it is a restriction in our domain, we call this an extraneous solution. Okay? And extraneous, gosh, can't spell today. Well, I can't spell most days, but, you know, it's whatever. So this is an extraneous solution, meaning we get it algebraically, but it doesn't work when we go back and check, okay? Because if I were to plug this in, we'd get a 0 in our denominator, which would be undefined, and it just wouldn't work, okay? So that's what we've got to consider when we're doing these problems, okay? All right, so on this next page, what we want to do is we want to say find all values of x for which y sub 1 is equal to y sub 2 and check. Okay, so y sub 1 is equal to 1 over x plus 4 plus 1 over x minus 4, and y sub 2 is equal to 22 over x squared minus 16. So what I want to do is set those two things equal to each other. All right, so I'm going to set up this equation here, 1 over x plus 4 plus 1 over x minus 4, and that's going to equal 22 over x squared minus 16. Now, what I'm realizing from this is that x squared minus 16 is difference of squares. So this can factor to x plus 4 times x minus 4. All right. So then I'm going to rewrite this over here, x plus 4 plus 1 over x minus 4. Now, because I have these separate denominators, x plus 4, x minus 4, and in this denominator I'm multiplying by each other, my least common denominator, LCD, is going to be the product of those two, which is just x plus 4 times x minus 4. Okay? And so what I want to do is I'm going to multiply my least common denominator through. However, let's talk about our restrictions. Okay? So my restrictions, what I want to do is take each of my terms and my least common denominator and set that equal to 0. Okay, so I'm going to do x plus 4 equals 0, and then I'm going to do x minus 4 equals 0. Here I'm going to subtract 4 from both sides, so I get a value of x equals negative 4. Here I'm going to add 4 to both sides, so I get a value of x is equal to positive 4. These are my restrictions. These make my denominator 0, so make fractions undefined. Okay? Now what I'm going to do, let's do the math and let's see what we get as far as answers go. So I'm going to do this. I'm going to multiply, I've got x plus 4 times x minus 4 over 1 times 1 over x plus 4 plus x plus 4 times x minus 4 over 1 times 1 over x minus 4. Okay? And then that's going to equal 22 over x plus 4 times x minus 4. We're going to multiply that by x plus 4 times x minus 4. Okay? Now, the cool thing that's going to happen is this. All right? Things are going to divide out. All right, so we're going to divide out the x plus 4s. We're going to divide out the x minus 4s. And then we're going to divide out everything over here, x plus 4s and x minus 4s. Okay, they gone. Okay, so now I've got this, x minus 4 times 1. All right, I'm just going to leave this as x minus 4 plus x plus 4. Okay, all this is times 1, so I don't need to really do anything. And then that's going to equal 22. Now, the cool thing is, and this is cool, okay, don't sit there and act like it's not cool. Negative 4 plus 4 is going to cancel out to 0. Okay, now here's what we're left with. We're left with x plus x is equal to 22. So this is going to give me 2x is equal to 22. Okay, let me move this up here. So 2x is equal to 22. Divide by 2, x is going to equal 11. Okay, now the cool thing is, guys, is that 11 is not part of our restrictions. Okay, so this is good. One last thing. Okay, and yeah, that's actually really nice that we get that. Okay, so yeah, that's that. That's what we get. So we can check this if we'd like, but I'm not going to right now. We don't have the time. Okay, now we've got a couple problems where we've got some different types of solutions. Let's see what happens when we solve these problems. So this is prompting me to distribute my 4. All right, so I've got 4x minus 7 is going to equal 4x minus 4 and then plus 3. Okay. So here's what we get. I get 4x minus 7 is equal to 4x. Negative 4 plus 3 is minus 1. Okay, now what I'm going to do is I'm going to do this. This is getting a little confusing here. Okay, I'm going to subtract 4x from both sides. Notice how the 4x's are the same on both sides. And what's going to happen is these are going to cancel out, and these are going to cancel out. So what I'm left with is this. Negative 7 is equal to negative 1. All of a sudden, my variables have been eliminated, okay? So that's the first thing about this. The second thing that I need you guys to see is that this statement here is false, okay? So if your variables get eliminated and you are left with a false statement, the conclusion that we draw is that there is no solution to this type of problem, okay? There is no value for x that will make this true, okay? So your variables are eliminated, okay? So variables are eliminated, okay? You get a false statement, so this is the first thing that happens. This is the second thing that happens. This is the third thing you need to say, that you have no solution, okay? And that's what we've got. Okay, let's take a look at the next one, all right? And on this, let's distribute the 9 here. So I get 7x plus 9 is equal to 9x plus 9, and then minus 2x. Okay, I'm going to combine my like terms, 9x minus 2x. That's going to give me 7x plus 9. On the left side, I have 7x plus 9. Notice something. Notice how I have the exact same thing on the left side as I do on the right side, okay? Now, what's going to happen is, let's combine my like terms. I'm going to subtract 7x from both sides, okay? Do that there, okay? And these both get eliminated and they cancel out, okay? So the variables are eliminated. But I guess since we're past April of 2011, Skynet exists, so we can call them, instead of eliminated, we can say terminated. Okay? If you've seen Terminator, then you would get that joke. But if you haven't seen Terminator, well, I don't know. Okay, so you're left with you're left with this. You're left with 9 is equal to 9. Okay? This is a true statement. Okay? And because that's a true statement, therefore you have infinite solutions. Okay, so any number that you plug in for x would work in this case. You would get a true statement. Okay, so these are just some special types of solutions. Okay, so hopefully you guys enjoyed this. I really do enjoy solving equations. It is one of my favorite things to do. You know, and that kind of helps when you got nothing to do on the weekend. So If you got nothing to do this weekend, go ahead and solve some equations and have some fun. All right, talk to you later. Thanks. Bye.